welcome to Cambridge Guru. I hope you are doing good. Last video which I uploaded on my channel was about a question which came in your AP. I think it was in AP AB part of your syllabus of AP calculus. So I thought that I should start a new lecture series on my channel. So here it is. From now on, I will be uploading the lecture series of your whole AP calculus syllabus, and I will be covering both AB and BC part of your AP calculus, right? So I will try to upload each and every topic of the syllabus, and yes, since I will be covering each and every topic in detail, so duration can extend to 30, 40 or 50 minutes depending upon the topic, right? So without wasting any time, let us start with the first unit, which is your pre-calculus review. Okay, wherein we will be studying some basic things, some basic topics that are required to go for advanced topic in calculus, right? Which will start basically from limits. Okay, so but before that, let us understand some basic things. Okay, so the first thing is your number system. So very first topic we will is covering some basics. So number system, basically what are numbers, right? No one is going to ask in the exam, so we will be covering subtopics, some concept which are not necessarily asked, means not by considering the point of view of the syllabus, but also some basics needs to be understood in order to understand the whole the system, whole syllabus. So what are numbers? Numbers are just a representation of the mathematical aspect of the nature. What I mean is that if I'm speaking something, right, I'm speaking a language, whether it is English, French or anything, so this is you are able to understand because you recognize the sound of each and every letter. But if I have to write something, whatever I'm speaking, so you need certain symbols to represent that language. Okay, so then comes your alphabets. Similarly, to represent the mathematical aspects of the nature, meaning if you have to count certain things, right, so you need you need some symbols to represent that mathematical concept or aspect of the nature. So the need arises of evolving some or deriving some number systems, right? So first number system came into existence earlier when the mathematics started, you can say, was the natural numbers. Okay, so we start with the number one system, which is natural numbers. So natural numbers are the numbers which start from 1. And why the need arises? Again, if we have to count certain things, so we will start counting by 1. Okay, 1, 2, 3, 4, so on. So the numbers which start from 1, 2, 3, 4, and so on till infinite, those are called natural numbers, and these are denoted by capital N. Okay, then second number system came into existence was the whole numbers. Now, if I ask you whole numbers, if I ask you that, let us say there are 20 chairs in the room or 20 students in a room, and I move out all these chairs, 20 chairs from the room, right? So, and now I ask the question that how many chairs are remaining in the room. So you will say that no chair will remain in the room. So you need certain symbol to represent that nothing. Okay, so which is, I mean, that nothingness in the nature you need to represent, right? So you need to represent that nothingness using a symbol which is your 0. Okay, although there are various aspects of this 0, why the 0 came into existence, but as far as number system is concerned, we have to include 0 also in the number system. So we'll start with 0, and its numerical value we say is less than 1. Okay, so 0, 1, 2, 3, these are called the whole number. So natural numbers plus 0 are your whole numbers, right? Third type of number system that came into existence was integers, or the directed numbers. Integers, okay, and or the directed numbers. Directed numbers. Direct numbers means, as the name is suggesting, that we need to represent direction also mathematically. What do I mean is that suppose I'm moving from my starting position 0. If I'm moving towards right, I am saying that I'm moving 2 kilometers towards right and I'm moving 2 kilometers towards left. So I need to represent this direction right and left with some different numbers, right? Although the distance is just same, which is 2 kilometers, but if I'm moving towards right, so we have made certain convention that if I'm moving towards right, those numbers are denoted by +2, right? Means those numbers are positive. Okay, and if I'm moving in the left direction of this my starting point 0, so the distance 2 towards left is represented by -2. Okay, so the whole numbers or the natural numbers with some negative sign behind it, or as a prefix, those are called the integers, right? So integers will start from minus infinity till, let us say, -3, -2, -1, 0, and then 1, 2, 3, and so on. Okay, so the set of all whole numbers plus negative natural numbers is your integers, which in short are denoted by a capital letter Z. Okay, sometimes we also denote these by I, capital I, right? And why we need a negative integer one is to represent direction. Similarly, the direction of means if I'm measuring the height of any building, height of any mountain from the sea level, from the ground level, so that height is represented mathematically by positive numbers, and if I'm measuring the depth below the surface, that will be represented by negative numbers. Okay, similarly, there may be infinite number of applications for these integers or directions or the negative numbers. For example, in temperature also. So if we are taking the reference point, which is 0 degrees centigrade, reference point in the sense that where the water freezes. So that freezing point of water, if we take as a reference value, so we denote that by 0 degree centigrade, and all the temperatures which are above this freezing point are denoted by positive temperatures, and the temperatures below its freezing point are represented by negative values, right? So that is, that is the reason of inventing with some new number system. That is the reason for inventing integers, right? Then we have certain other types of uh, number system, which is your rational number. Rational numbers denoted by capital Q. Okay, and the definition is very basic. All of you must have known this, that any number which can be represented in the form of P by Q, right, and where Q should not be equal to 0, right, where P and Q are integers, right? P and Q are integers, except that Q cannot be equal to 0. P and Q are integers. Q cannot be equal to 0. So all those numbers which can be written in some fraction form, okay, are called the rational numbers, and they possess certain properties, and depending upon that, these are subdivided into two number system. This A part is those rational number which are called terminating. What are terminating numbers? If we find out the decimal equivalent of that rational number, means if we divide and we get a final digit, for example, let us say you are writing 3 by 5. So 3 by 5 is a rational number. It is following every rule to be called as a rational number. 3 and 5 are integers, and 5 is obviously not equal to 0. So we say this is a rational number. And if I find out its decimal equivalent, you obtain 0.6. So means there are no further digits after this 6. We have divided 3 with 5 completely, in the sense that there are no subsequent digits after this, no matter there is a point in this, obviously, right? So this is called the terminating rational number, right? There are other types of rational number also which are non-terminating rational numbers, but they are repeating or recurring. Means the digit after a certain digit is repeating, right? For example, if I take the number 1 by 3, again this is a rational number. 3 is not equal to 0 and 1 and 3 both are integers, but if you take out the decimal equivalent of this, this will be 0.3333 and so on till infinite. So we have non-terminating, means these digits are not terminating but they are repeating. Okay, 3 is repeated n number of times, okay, or infinite number of times, and in short we write or denote this by a bar, 0.3 bar. Okay, similarly 2 by 3 is another non-terminating number, right? 4 by 6 is also a number. 5 by 6 is again a non-terminating number or rational number, right? Next comes the irrational number, right? Irrational numbers, the definition is just opposite of rational number. Irrational number, there is no particular notation for denoting these. Okay, so irrational number, those number which cannot be, okay, numbers which cannot be represented in the form of p by q. Okay, which cannot be represented in the form of p by q are called irrational numbers, right? So what are those numbers which cannot be represented? So example is square root of 2. Okay, all these surds, means all these roots, whether it is a square root or a cube root. If I'm talking about a square root, so square root of any non-square number will be an irrational number, right? So 2 is not a square number, so its square root will be an irrational number. Okay, so if I find out the decimal equivalent of all these irrational numbers, you won't get a terminating number, you won't get even a repeating number also. Okay, so the property of these irrational number is that they are non-terminating, just like the b part of rational numbers, but only difference is they are non-terminating and non-repeating or non-recurring. Okay, in these type of rational numbers, 1 by 3, 2 by 3, right, 4 by 6, okay, all these were rational numbers. Decimal equivalent, they don't have any uh, terminating digit, but the digit will be repeated after a certain number of digits after the decimal point. But in these irrational numbers, there is no pattern of the numbers, right? All the numbers will just occur randomly. So if I find out the decimal equivalent of root 2, meaning root 2 is equal to 1.414, I remember just here. Okay, so after this there will be, you won't find any pattern in the digit after this. Okay, so you cannot find out the exact value in decimal form of the irrational numbers. That's why these are called the irrational. Okay, but these numbers exist in nature. How these numbers exist in nature, meaning if we are calling them as irrational, then what is the use of studying this? So you just imagine that Pythagoras theorem exists in the nature, and if you take out let us say this side as 1 unit or 1 kilometer, 1 meter, 1 centimeter, and the perpendicular side both are of 1 unit. So if you find out the hypotenuse of this triangle, you can form practically. So this length will give you root 2. If we apply the Pythagoras theorem, this will give you 1 square plus 1 square, which is 1, and square root of this will be 1 square plus 1 square is 2. So square root of this will be root 2. So this length do exist in nature, right? So irrational number exist in nature. It is just like we cannot find out their exact value. Exact value in the sense the decimal equivalent of this. Another example of irrational number is very well known, which is pi. Okay, if I'm saying that 22 by 7 is a rational number, so why we are saying that pi is an irrational number? This 22 by 7 is in fact again an approximation of the value of pi. Okay, and 3.14 is again the approximation of the approximation, right? So pi is again an irrational number. There is a number which is called E, okay, Napier's constant. which is very widely used in calculus. Okay, we will see the properties of this function, exponential function e raised to power x, but for now this e has certain value 2.6 something, I think, or 2.4, right? So again, this is an irrational number. Okay, so there are irrational numbers which exist in nature and they do have certain physical significance. All right. Okay, now there comes a last number system which comprises, or which is the superset of all these numbers, which we say are is real numbers. Real numbers which are denoted by capital R, which will be widely used in calculus. Okay, so this is all those numbers, meaning integers, whole numbers, natural numbers, rational numbers, irrational number. The superset which comprises of all these numbers is the are called real numbers. Okay, so as far as your calculus AP is concerned, there is another number system which is the complex number. You must have known this, right? But calculus in your syllabus is only related to the real numbers. Okay, we are not dealing with the complex numbers calculus, although calculus is very well applicable in complex number system also. Okay, but that we are not doing in AP syllabus, right? So if I denote this by certain diagram, so I can use these circular diagrams. That first number system is your n, means the natural numbers. Then if I add 0 to these natural numbers, that set is your whole number. So this is your 0 and I am calling this as whole numbers by w, right? Then comes the integers. Okay, so all the positive whole numbers are here, and if I use the negative numbers also, so there comes the set of integers, right? Then there comes a set of rational numbers, right? Why I'm saying that integers are inside the rational numbers? Let us take an example that if I take the integer as 5, can I say that 5 is a rational number? Of course it is a rational number, because every integer can be written as 5 by 1. There is always a 1 in the denominator of each integer, whether it is positive or negative. Minus 9 over 1. Okay, and it is following each and every property of an irrational number. Oh, sorry, of a rational number. So 5, all the integers are called as rational numbers. And okay, this is, excuse me, this is not R, this is Q. Okay, this is Q, and the superset of all these, the last set of number system, is your real numbers. And somehow in between these there are irrational numbers also. We cannot draw an irrational number like this, because we cannot call an integer as an irrational number, neither we can call an irrational number as a some integers or whole numbers. Okay, so those will be in the real number only. Okay, you can form a slight set within the real numbers which must be outside all these rational integers or the whole numbers. Okay, you can call these as irrational numbers. Okay, so this is the circular diagram in order to understand the number system. So if I ask the question, are integers real numbers? So since integer circle is inside the real number circle R, so we say that yes, this all the points which are lying inside I will definitely be lie inside R. So all integers are real numbers. But vice versa is not true. For example, can I say that all rational numbers are integers? No. There are certain rational numbers which are lying inside this circle, which won't fall inside the integer circle. Okay, so these numbers are rational numbers, but they are not integers. Yes, all integers are called as rational numbers, just I spoke about that. Okay, so this is all about the number system. Okay, these are very basics, but you need to understand these, right? Our next topic is absolute value, right? Remember, when we say that what is the absolute value of -4, okay, so what we mean by absolute value is we find out the magnitude only. Okay, so we are interested in finding out just the magnitude of a quantity or a number. Okay, so if I'm saying that I am living in a region which is at whose let us say average temperature is -4 degrees centigrade. Okay, so I'm not very basically interested in finding out the minus or plus. I'm just interested in finding out the magnitude of the temperature. It is just 4 degrees. Okay, you can call this in the sense of direction also. Direction in the sense that if I'm moving, I'm only interested in finding out how many kilometers you have walked in the morning. Whether you are moving towards east or you are moving towards left, it doesn't matter. Okay, I just need that if you want to stay fit, how much kilometer you are jogging or walking. Okay, so I'm just only interested in finding out the absolute value. Okay, so those absolute value of a negative number is represented by drawing these two vertical lines, and the answer will always be positive. We say that this is the modulus magnitude, or we also say modulus. Okay, because later on we will define the modulus function. We will study some properties of this modulus function, and we will revisit this again. Okay, and obviously magnitude or modulus or absolute value of a positive number will be positive. Okay, so in order to understand the properties of this absolute value, we understand with a concept of which is called the distance from the starting point. Okay, it basically gives you the distance. What I mean by this is that if I say that my distance I have traveled, let us say 3 kilometers. Okay, so now there are two options, that either I travel 3 kilometers towards right, or I can travel 3 kilometers towards left. Okay, and I'm saying that I am traveled 3 kilometers. So this statement is mathematically be represented by mod x is equal to 3, that my distance is 3. Okay, now if you have to introduce the directions, right, so you will say that x is 3, so this represents that I'm moving towards the right, and this will give you x is equal to -3 if I'm moving towards left. Okay, if x is -3, then again its magnitude will be -3. It is just the representation. Okay, so this mod x equal to 3, it represents your distance from the starting position. In this case, this starting position is 0 from the origin. Okay, so mod x equal to 3 is the distance from the origin. And what is the distance? It is 3. So either I am moving towards right, so I arrived at this 3, or I am moving towards left, then I will arrive at -3. Now, if I'm talking about the function in the sense of a function, so this will be equal to x. Okay, this quantity will be equal to x if I say that this x is positive. For example, let us take x value as 5. So mod of 5 will be 5, right? And it will be equal to -x if x is negative. Okay, 0 you can apply either in this or in this, right? What I mean by this is, you might be getting confused that since mod x is always positive, how come you are writing this as -x? But you understand here is that this x is in itself negative. Okay, this x is in itself negative, so negative into negative will give you positive value, and that is the reason why the modulus or the absolute value gives the positive value. Here in this case, x is in itself negative, so if you are interested in finding out the positive value, you need to apply a negative sign outside it. Okay, so this is the formal definition of the absolute value function or the modulus function, and it basically represents the distance. Okay, so uh, here it is that, for example, 1.2 magnitude will be 1.2 and -8.35 magnitude will be just positive 8.35, right? And the absolute value satisfies these two inequalities, that mod A will be equal to the negative mod A, and mod of A into B is equal to, you can separately take out the magnitude first. For example, if you are writing -4 into -3, then its magnitude, this is 12 magnitude, which is equal to 12. And if I take out the separate sign of this, minus 4 into modulus of minus 3, which is 4 into 3 is again 12. So mod A B is equal to modulus of A into modulus of B. Okay, but what will happen if I say that mod of x minus 1 is equal to 3? Okay, now opening this statement using the formal definition, I can write this equation mod of x minus 3 as x minus 1 is equal to plus 3, or x minus 1 is equal, or I should write column wise, okay, or I can write this x minus 1 is equal to minus 3. This is a simple definition, right? Either it will be plus 3 or it will be minus 3, right? Solving this, x will give me 4, and solving this, x will give me minus 2. Now what is going on actually? Let us understand this using a number line diagram, right? So we have here that I have moved 3 unit distance. Mod of x minus 1 is now equal to 3, meaning I have moved 3 unit distance. Okay, but solving this equation gives me x equal to 4, right? And solving this equation gives x equal to minus 2. This is only possible if my starting position is plus 1, not the origin this time. So if I'm moving from plus 1, right, and I'm moving 3 distance towards right, x minus 1 equal to 3 represents that from the starting position 1, I have moved 3 distance towards right. Why right? Because it is plus 3. Okay, so if I'm moving plus 3, I reach at plus 4. That's why x is equal to 4. But if I move towards left, this left direction is represented by minus 3. If I move 3 units towards left, I arrive at, this is your 0, 1 unit, this is your minus 1, 2 units, and this is minus 2, 3 units. So if I move 3 units towards left, I arrived at minus 2, which is represented by the solution of this equation. Right, so basically x minus 1 mod is equal to 3 represents the distance traveled from the starting point, which is 1. Okay, so in general, if I say mod of b minus a, it represents the distance which you have moved from the or from a, which is your origin or the starting point. Okay, now this is the thing for absolute value. And what do you mean by a modulus function? Let us now extend this concept with modulus inequality. What will happen if I write mod of x minus 1 is less than 4? So again, it is just a difference of the sign. Earlier it was equal to 3. Here we have less than 4. So again, understanding this modulus inequality with the definition of the distance. Remember that it represents x minus 1 mod is less than 4. It represents a distance of 4 units starting from the point 1, but this time this distance is less than 4. It is not equal to 4, right? So in simple words, this modulus inequality represents that my distance from the starting point 1 should be less than 4. Now there are two cases that arise. One is that since my distance from the starting point, this is my starting point 1, this should be less than 4. So either I am moving in the positive direction, then my distance should be between 0 and 4. Okay, I should move between these 2 points, not 0, 1 to 4. I should move between these 2 points, 1 and 4. I cannot travel beyond this 4, right? Again, and then if I'm moving in the negative direction, then my distance should be between 1 and minus 4. Okay, this distance must be, I'm not saying that this point is minus 4. Okay, this distance, this magnitude, okay, from 1 towards left, it should be a -4. Okay, so either 4 units I'm moving towards right or 4 units I'm moving towards left. I'm not asking that what will be the point here. Okay, it can be 3, 2 or anything. That will be, we will derive, okay, that we will solve what exactly this distance will be. Okay, but in simple words, it is that my distance should not be greater than 4. So either I will travel 4 units towards right or less than 4, or it will be greater than -4, because all these values which are lying between 1 and this negative number, those values will be negative, their magnitude will be less. But if I talk about the negative numbers with a sign, their value will be greater than, right? So if this point is -3 and this point is -2, so obviously -2 is greater than -3, right? So all these distances will be greater than. Why I am saying this? Because I need to open this modulus inequality. How I will open up this? That if I'm moving towards right, so x minus 1 must be less than 4. Simple. Or if I'm moving towards left, then this x minus 1 should be greater than -4. And that is the thing which confuses most of the student. That it greater than -4 because all these distances will be greater than -4. Okay, because these I'm moving in the negative direction, so I need to change the sign of the inequality, right? And now you can easily solve this, that either the x should be less than 5 or here x should be greater than -3. Okay, so again drawing these or representing these on the number line, my starting point was 1. So if I am moving 4 distance towards right, not greater than 4, so maximum I can reach at 5 point. And if I'm moving towards left, minimum I can reach as -3. So these two solutions are represented in this number line. Okay, so that's how you will open up a modulus inequality. Okay, always consider the distance thing in your mind and then open these inequalities, right? Similarly, if I take the another case, instead of less than, if I say mod of x minus 1 is greater than 2, so this time understand this, that my starting point is 1 and I'm moving the distance greater than 2. Okay, not less than 2, greater than 2. Okay, so either I am moving towards right direction or I will move towards left direction. So here is your number line, this is your starting point 1, this is your 2, so either I will move greater than 2, right, and this is less than this point. Okay, I'm not solving what exactly this point will be. Okay, right, so this distance should be greater than 2 units. This distance is your 2 units. Okay, this distance is also 2 units. So this distance should be greater than 2 units towards right and towards left. Okay, so what this exactly point will be, that will be open up like this, that if I'm moving towards right, then x minus 1 should be greater than 2, or if I'm moving towards left, then x minus 1 should be less than -2, because those quantities which are towards left of this value, okay, will be less than this -2 point. Okay, so x minus 1 must be less than -2. So here it gives x is greater than 3 or x is less than -1. Okay, so this point will be -1 and this point will be 3 if I have to move greater than 2 units. Okay, you can take the difference between 3 minus 1 is 2, and you take the difference between -1 and -1, it is also 2. Okay, I think I have spoken too much about the modulus inequality and all this absolute value, but it should be understood in detail. Okay, all right. So next is types of intervals, right? In a number line, if the numbers are included in the solution, right? So if this point A and B are included, those are represented by solid circles, right? And it is represented by the square brackets a comma b. Okay, if a and b are included in the solution, then a and b are represented or put it inside a square bracket. Okay, and if these are not included, meaning this example in which a and b are not included, these are represented by an open circle, and in the bracket terms they are inside a parenthesis. Okay, so if any solution set is represented by a comma b with parenthesis, it indicates that a and b are not included. In this, a and b are included in the solution set. Okay, and if one point is included, one point is not included, like in third case, so here a is included, b is not included, partial brackets are also used. So a comma b with parenthesis, it indicates that a is included, b is not included, and vice versa of this, that half open interval for a, b, here b is included, a is not included. And if anyhow you arrive at a and b, one of the points as infinite, so always put a parenthesis wherever infinite are, or infinite is the solution set, is in the solution set. Okay, like this. And if both the points are infinite, so we will use parenthesis only, because there is no exact value of infinity. Okay, now how we can represent this intervals, because earlier was modulus inequality and we were dealing with intervals. Okay, so how we can represent the intervals using the modulus inequality, and vice versa, representing inequality into intervals, right? Question can be of that representing intervals in terms of an inequality, modulus inequality, right? So how we can use this? It says that if any inequality of the type x minus a mod is less than r, right? So it simply indicates that I'm moving r distance, maximum r distance I can move from the starting point a, right? Meaning is that my starting point here is a, and this distance maximum can be a plus r if I'm moving towards right, or this distance could be a minus r if I'm moving towards left. Okay, that's how you will arrive at these starting and finishing point. Okay, for example, like this. Okay, or let us take one example, let us say minus 2 and 2 here only, and minus 2 and 2 are included. Now we have to represent this using using a modulus inequality, right? So always write this, that upper limit will be a plus r and lower limit will be a minus r, right? So here a plus r will be equal to plus 2 and a minus r will be equal to minus 2, right? Lower value. If you do not want to go directly, you can open up this inequality, right? X minus a mod is less than r, meaning is that x minus a is less than r, or x minus a will be greater than minus r, just like I opened up this inequality. Okay, this one, x minus 1 is less than 4, or x minus 1 is greater than minus 4. Now here we have 1 and 4 as a and b, so likewise this will be opened up as x minus a is less than r, or x minus a is greater than minus r, right? Again, talking in terms of distance, that I have to travel less than r distance from the starting point a, right? So x minus a must be less than r, or x minus a should be greater than minus r, meaning I need to be between plus r and minus r. Okay, so solving this will give you x is less than a plus r, or x is greater than a minus r, right? So your solution set will be, this is a plus r and this is a minus r. So you can directly write that in any interval, if it is given minus 2 plus 2, so upper limit will be your a plus r and lower limit will be a minus r, if a and r both are positive. Obviously we will consider this. Okay, so a plus r is 2, a minus r is minus 2. That means solving this is that 2a is equal to 0. That means a is 0 and r is 2. Okay, so starting point in this case is 0. Your a is 0, so representing this by x minus 0 mod is less than 2, or mod x is less than 2. And going in the reverse direction, if I have to find out the intervals, right, so mod x less than 2 basically is I'm moving between minus 2 and plus 2 from origin. That this distance should be 2 units, and this distance also should be 2 units, left and right directions. Okay, so this is how you will represent any parenthesis or square brackets inequality into a modulus inequality. Now, third type of inequality is quadratic inequalities. As you know that if any function fx is given to you like this, ax square plus bx plus c, where a is not equal to 0. Okay, this is the complete definition of a quadratic expression or a function, that this coefficient should not be equal to 0, then we say that this is a quadratic expression or quadratic function, right? Now, if this is a quadratic function, there are two types of graphs that a quadratic equation resulted. One is, it can be a U-shaped curve. This is for if a is greater than 0. And it can be an inverted U-shaped curve. This is a case where a is less than 0. If a is greater than 0, example could be any quadratic expression of x square plus 2x plus 1. And if it is less than 0, example could be minus x square plus 2x plus, let us say, 4. Okay, so these are all the quadratic expression. Here the leading coefficient a is negative, so it will be an inverted U shape. If it is positive, it will be a U-shaped curve. Okay, now if I'm interested in finding out the quadratic inequality, how to open up the modulus quadratic inequality. Okay, now there are two cases. One is that if you have been asked that ax square plus bx plus c is greater than 0. Okay, solve this quadratic inequality, right? So first thing is finding out the roots of this quadratic equation, ax square plus bx plus c is equal to 0, right? Let us consider that the roots of this equation are alpha and beta. So I can represent this like x minus alpha and x minus beta. You can take a outside if you want to, and this is greater than 0, right? If I have to represent this graphically, you can call this that this is your x-axis, and let us say this earlier root is your alpha and this root is your beta. Okay, now I am interested in finding out the range of values of x for which this expression is positive. This expression is positive or this expression is positive. Now seeing the graph here, it says that after this, all the values of x which are greater than beta, all the values of x which are greater than beta, here you can see the curve is above the x-axis, meaning the function is positive for all the values of x which are greater than beta, right? And also function is positive for all the values of x which are less than alpha. Okay, so for all these values of x, function is positive. For all these values of x, function is positive. So we have two types of solution in this, that if this is solution set will be that x is minus b is greater than 0, or x minus alpha is less than 0 if alpha is less than beta, obviously. Okay, I'm talking about this particular situation where alpha is less than beta. Okay, your first root I'm taking as alpha. So here x is greater than beta or x is less than alpha. Okay, if you understand the graph, right, that's why first thing is to plot the graph in your mind or in any rough book. Okay, and understand the nature of the curve, whether it is u or v, right, whether it is u or inverted u, right? Then second step is finding out the solution of or the roots of the quadratic equation, represent that roots as alpha and beta, and just see that where the graph is positive and negative, right? We can reverse this inequality by asking that find out for what values of x the function fx is less than 0. The function fx is less than 0 where, as you can see in the graph, between alpha and beta. That means for all the values of x which are less than beta and greater than alpha, this is for less than 0. That's the thing. Okay, but if a is negative, what about this scenario? What about the quadratic function is inverted u shape? Okay, if you say that the same roots are alpha and beta, okay, this is beta, and if I ask you for fx greater than 0, but this time, as you can see, that function is positive between these two values of alpha and beta. So this time for fx greater than 0, solution of set will be between alpha and beta. Okay, solution set will be between alpha and beta, which is just the opposite for this curve. Here between alpha and beta, that solution set will be for fx less than 0. But if it is inverted u, for fx greater than 0, the solution set is alpha and beta, and vice versa, right? If I ask for fx less than 0, as you can see that fx is less than 0 for all the values of x greater than beta, for the values of x less than alpha. So what we should do when we need to remember this, whether the curve is negative, positive, I mean, the things are very complicated. So the simple thing is, what you do here is, in order to solve a quadratic inequality, what you do is, very first step is make the coefficient of x square as positive. Make the coefficient of x square as positive. Okay, for example, if it is minus 2x square, means solve this, minus 2x square plus 4x plus 2 less than 0. Okay, first step is making the coefficient of x square positive. You can also add by multiplying by minus 1. How we can make the coefficient positive? By multiplying by minus 1 or by transferring negative term to the positive side. Okay, so the moment I multiply this inequality by a negative number, this will become 2x square, this will be minus 4x, this is minus 2, and the sign will be reversed. Instead of less than 0, it will become greater than 0. Reason why? You need to think and write this in the comment section, why the sign of the inequality needs to be reversed when we multiply a negative number, when we multiply an inequality with a negative number. All right, so first, if in the first step, when we make this x square coefficient as positive, then it's a piece of cake. You carry on with this, find the roots of this, find the roots as alpha and beta. Then for fx less than 0 or greater than 0, solution is outside the roots, in bracket I'm talking about x less than alpha or x greater than beta. Remember in the previous one, if you see here, outside the roots meaning for x greater than beta and less than alpha, I'm moving outside the roots, function is positive. Okay, and between the roots, function is negative. And for fx less than 0, solution is between the roots, that is x is less than beta and greater than alpha. Okay. And last thing is, uh, see, this whatever we have derived, it is again a shortcut method. Shortcut in the sense I am not going into the various cases in this, okay, because there are various cases involved. How we have arrived at this is basically, since I am writing this fx as x minus alpha, multiplication of two numbers x minus alpha into x minus beta, and it is positive. So now there are two cases arise, which is that it is a multiplication of two numbers. Multiplication of two numbers will be positive, it is saying. So for what values of x, these two multiplication is positive. So there are two cases that either both the numbers will be positive or both the numbers will be negative, and we take the intersection of those 2 points. So case 1 is when both the numbers are positive, meaning x minus alpha and x minus beta both are positive, will give you x is greater than beta, right, intersection. And second is when both the values are negative, meaning x minus alpha is less than 0, means x is less than alpha and x is less than beta. Intersection will give you x is less than alpha. Okay, so two cases for greater than and two cases for less than. Okay, intersection of all these value or the common points of all these solutions, finding out the common points of all these solution will give you the above results, right? That outside the root will give you the positive value for fx greater than 0, and between the roots will give you the values of x for which fx is less than 0. But remember, for this we need to first make the coefficient of x square as positive. And same scenario arises when we divide two numbers. So inequalities of the type x plus a over x plus b, right, greater than 0 or less than 0. So just like we gave the solution for a quadratic inequality in which two numbers or the two roots are written like this, x minus alpha and x minus beta, or any quadratic expression written by x minus alpha, x minus beta, we take this as multiplication of two numbers, one is x minus alpha and x minus beta, and arrive at this result. Same result can be applied for the two numbers which are in division, because division of two positive numbers will give you the positive value, and division of two negative numbers also give you the positive values, right? So this solution or these statements are also valid for inequalities of the type x plus a upon x plus b. So solution set for this, for greater than 0, is again outside the roots, right? So x is greater than b or x is less than a. In this case it will be minus b and minus a. You just make up this as minus a and minus b in order to avoid the confusion. Okay, and yes, you have to decide whether a is greater or b is greater. Okay, so this is it about the inequalities. Now let us solve a couple of questions what we have learned in today's lecture. Expressing the following intervals in terms of inequality involving absolute value. This we have learned. Okay, first one is already done. Let us take the second one. Since upper value, we need to represent this like this: x minus a is less than b. This is the inequality which the question is asking about. We need to find out value of a and b. So upper value, which was denoted by a plus b, in this case it is 4, and lower value is a minus b, in this case it is 0. If I add these two, we get 2a is equal to 4, meaning a is 2 and b is 2. So your inequality is x minus 2 mod is less than 2. And remember, here 4 and 0 are not included, so we are not applying any inequality sign. Okay. In the third case, you can see that a plus b is 0 and a minus b is minus 4. So here a is minus 2 and b is 2. Yes. Okay. So this is represented by x plus 2 mod less than equal to 0 this time, because here 0 and 4 are included in the solution, so those endpoints in inequality are included. Okay, so less than equal to 2. So x plus 2 mod is less than equal to 2, right? Similarly, you can do the fourth one as your homework. Then solving the inequality of the type, again we are doing the reverse process. This all you very well know, right? If you have to do the third part, I'm not considering this x square plus 2x less than greater than 2. Let us take an example of, from my side only, how to solve a quadratic inequality question. Solve x square plus 2x plus 1. No, plus 1 no. X square plus 2x mod is greater than 1. Okay, let us solve this. Now if I have to open up this, there will be two quadratic inequality. One will be positive, this is greater than 1, right? Or x square plus 2x is less than minus 1. Okay, since coefficient of x square is positive, so we do not need to multiply any negative number, right? Meaning x square plus 2x minus 1 is greater than 0, or x square plus 2x plus 1 is less than 0, right? We cannot solve directly by factorizing, so we need to use the quadratic formula in order to find out the roots of this quadratic equation, right? So it will be minus b, so minus 2 plus minus b square minus 4ac, it will be plus 4 under root over 2a. A is just 1. So here you will give minus 2 plus minus 2 root 2 divided by 2. So here I have the roots as minus 1 plus minus root 2. Okay, so I can write this as x minus of 1 plus root 2 multiplied by x minus of minus 1 minus root 2. Okay, and here we have x plus 1 whole square less than 0. Can x plus 1 whole square be less than 0? So it will be no solution for this. As far as real numbers are concerned, meaning if as far as x is real, this whole square cannot be negative, so it will give you the no solution. So we need to just find out for this inequality, right? So which value will be less than minus 1 minus root 2 or minus 1 plus root 2? Okay, so here is your number line. I think minus 1 minus root 2 is less than, so minus 1 minus root 2 is your first root, and minus 1 plus root 2 is your second root. This will be plus, this is minus, this is plus. This is also known as wavy curve method, but we just have got to our algorithm that outside the roots we need to look for greater than 0, and roots are minus 1 plus root 2 and minus 1 minus root 2. So here the solution is that x is greater than minus 1 plus root 2, or x is less than minus 1 minus root 2. Okay, this is your solution. This inequality won't give you any solution. Had it been given any solution, then we will take the intersection of the points. Let us say it is giving me x is less than minus 1, right? So now we need to look for that it should satisfy this also and this also, right? So here it is minus 1 minus root 2, so minus 1 somewhere will be lying here, right? So we need to include this value and this value. So again the intersection will be minus 1 minus root 2 only, because this value or these values of x are not common with these values of x, right? So in that case we need to find out the intersection of the points. Okay, and last question for the day is x upon x plus 1 less than 0. Okay, x over x plus 1 is less than 0. Okay, now it is asking For less than 0, as I told you, that the same concept will be applied. For less than 0, between the roots. So roots of these two linear equation will be, one root is 0 and one root is -1. So here is your number line. This is 0 and this is your -1. Okay, and less than 0 is between the roots. So simple solution for this is that x is less than 0 and greater than -1, meaning the between the roots. Okay, so that's it for today. As I told you that it depends on the topic, duration of the lesson will be big, can be big, and it actually happen. All right, so see you in the next video of pre-calculus review unit 1 calculus AB, and do like, share and subscribe my channel, and share this link of the YouTube video to your friends, those who are preparing for AP calculus, and any, if they are interested in understanding the mathematical concepts. All right, take care, bye bye, see you in the next video. Thank you.